All right, let's kick off this deep dive. Today we're looking at continuous delivery, and we've got some great excerpts from the book Continuous Delivery. Reliable software releases through build, test, and deployment automation.
Sounds exciting.
It is. It's all about, how to make software releases smooth and reliable.
And frequent.
Yes, frequent too. Like, what if releasing software was as easy as ordering your favorite food online?
Right. You just click a button and boom, it's there.
Exactly. That's the goal of continuous delivery. No more late nights stressing about deployments.
I like the sound of that. One thing that really struck me about continuous delivery is how it changes the whole game of software development.
Oh, how so?
Well, it's not just about churning out code as fast as you can. It's more about constantly testing your ideas and making sure they actually work for the users.
So it's less about big, infrequent releases and more about getting constant feedback.
Yeah. The book compares it to running a bunch of little experiments.
Ah, I see.
Each release is like a hypothesis, and the user feedback tells you if you're on the right track or not.
Makes sense. But how do you actually make those rapid releases reliable? I mean, pushing new code all the time, it seems like it could get messy.
It could, if you're not careful. That's where the deployment pipeline comes in.
Okay, tell me more about that.
Imagine like an assembly line, but for your software.
I like where this is going.
Instead of workers, you have automated tests at each stage.
Gotcha.
From the moment the code is written to the final release, everything goes through this pipeline. It catches errors, ensures quality, the whole 9 yards.
So it's like a built-in safety net to prevent bad code from reaching users.
Exactly. And the more you automate in this pipeline, the better. The book really emphasizes that.
I can see why. Less manual work, less room for human error.
Right. It frees up your team to focus on things robots can't do.
Like, what kind of things?
Oh, the creative stuff. Coming up with new ideas, solving complex problems.
Right, right. But you'd still need humans for things like testing, right? And getting feedback from users.
Of course, you can't automate everything. There's always a need for human intuition.
I was just thinking about that.
But even with testing, you can automate a huge chunk of it, especially the boring, repetitive tasks that can really bog down a team.
I bet. Now, one thing the book really dives into is version control.
Ah, yes. Version control.
And it's not just about keeping track of your code, right?
Right. They suggest putting everything related to your software into version control. Tests, scripts, configurations, documentation, the whole shebang.
Wow, everything. That's a lot.
It is, but it's worth it. It's like having a complete history of your project. You can see every change that was made, who made it, and why.
So it's like a time machine for your software.
Exactly. And it could be super helpful if things go wrong.
Like if a new feature causes problems in production.
Yeah. You can rewind back to a previous state, see what changed, and fix it quickly.
Makes sense. It's like having a safety net. But I was curious about something. The book says you shouldn't store binaries in version control. Why is that?
Oh, that's a good question. It's mainly about efficiency. Binaries are those compiled code files that can be huge. They just bloat your repository.
So it's about keeping things lean and clean.
Exactly. Plus, you can always regenerate binaries from the source code, so there's no need to store them.
Okay, that makes sense. Now let's switch gears a bit. The book talks about building software with components, and they use this awesome Lego analogy.
Ah, yes. The Lego blocks. That's such a good way to think about it.
It is. So you're basically saying you build complex systems from smaller, independent pieces.
Right. Just like with Legos. Each component has a specific purpose, and you can assemble them in different ways.
So you're creating reusable building blocks for your software.
Exactly. It makes the system more flexible and easier to maintain because you can update or replace individual components without affecting the whole thing.
Like swapping out a Lego brick. I love that analogy. But what about managing all the connections between those pieces, those dependencies between components?
Yeah, that can get tricky, especially as your system grows. It's like imagine a giant web of connections between all these components.
I can see how that could get tangled.
Right. But luckily, there are tools like Maven and Ivy that can help. They act like librarians for your components.
Ooh, librarians. I like that.
They fetch the right versions, resolve conflicts, make sure everything fits together nicely.
Those tools sound like lifesavers. So we're building this amazing software structure with well-managed Lego blocks. We have version control as our time machine. But what about branching strategies?
Branching, that's a big one.
It is, especially when you have multiple people working on a project. How do you keep the code organized and prevent conflicts?
Well, there are a few different approaches, like developing on the main line, branching for releases, branching by feature.
I see. I
The
see.
book dives into those, but they have a strong opinion on one approach in particular.
Oh, really? Which one?
They strongly advocate for developing on the main line as much as possible.
Interesting. So avoiding branches unless you absolutely have to.
Exactly.
That's surprising. Wouldn't working on separate branches prevent conflicts?
It seems that way at first, but merging frequently, even if it feels messier initially, actually leads to fewer problems down the road.
It's like ripping off a Band-Aid quickly rather than slowly peeling it off.
Yes. It might hurt a bit at first, but it's better in the long run. And it forces everyone to stay up to date with the latest changes, which is good for communication and collaboration.
That's a really interesting perspective. Now, before we get too deep into the code, let's talk about data.
The data, yes, that's an important part.
It is. The book reminds us that databases are often overlooked, but are crucial for continuous delivery.
Absolutely. And managing database changes can be a real headache, especially when you're releasing software so often.
Can you imagine? What are some of the challenges?
Oh, things like updating the database structure, migrating data, managing test data, it can get tricky.
So, how do you prevent data management from becoming a bottleneck?
Well, the book suggests a few strategies. First, just like with your code, automate as much of the database setup and migration process as possible.
Okay, automation again.
Right. It reduces the errors and ensures consistency. And second, they talk about techniques like blue-green deployments.
Blue-green deployments. I've heard that term, but can you remind me how it works?
Sure. You basically have two identical production environments. One is live, the other's on standby. You deploy the new version to the standby environment, test everything, and then just flip a switch to redirect traffic.
Ah, I see. So it makes for seamless releases with almost no downtime.
Exactly. It's a really clever way to handle database changes.
That's brilliant. Now, let's be realistic here. Even with continuous delivery, there's always some risk, right?
Of course,
Mm.
no system is perfect. Continuous delivery doesn't eliminate risk entirely,
Right, right.
but it helps you manage those risks better.
So it's about having the right tools and being proactive.
Exactly. The book emphasizes identifying potential risks early on, having mitigation plans in place, and using an iterative approach to address them.
Okay, that makes sense. It's about constantly adapting and learning as you go.
Precisely.
There's this interesting example in the book about a project where database changes accidentally caused data loss during a release.
Oh, yes, I remember that example.
Mm.
It really shows how even small changes can have big consequences.
It does. It highlights the need for really thorough testing and a robust release strategy.
Absolutely.
Yeah.
Even with continuous delivery, vigilance is key.
Okay, speaking of constantly evolving, let's talk about infrastructure as code.
Ah, yes, infrastructure as code. It's a game changer.
The book highlights it as a key concept for continuous delivery. But for someone who might not be familiar, can you break it down?
Sure. Instead of manually configuring your servers and infrastructure, you treat it like code.
Okay.
You define everything in configuration files, you version control them, and use automated tools to manage everything.
So you're basically writing a script that sets up your entire IT infrastructure.
Yeah, pretty much.
That's amazing. But what are the real benefits of doing it this way?
Oh, tons of benefits. For one, it eliminates those manual configuration errors, which can be a real pain to track down.
Oh, I bet. I've had my fair share of those.
Right. And it makes your infrastructure more reproducible. You can spin up new environments quickly and easily, knowing they'll be configured exactly the same way.
So it's about consistency and repeatability.
Exactly. And don't forget testability. You can actually test your infrastructure code, which is huge for maintaining reliability.
Wow, it sounds like a completely different way of managing IT. Are there specific tools that help with this?
Oh yeah, definitely. Tools like Puppet, Chef, and Ansible are incredibly powerful for this. They're like your virtual IT administrators, taking your configuration files and setting everything up automatically.
Like having a team of robots managing your infrastructure? That's amazing.
It is. And it frees up your team to focus on the things that really matter, like building great applications.
I can see why that's so appealing. Okay, last but not least, let's talk about what happens once our software is out in the wild.
Ah, yes.
Monitoring.
Monitoring. The book really emphasizes its importance. Can you elaborate on why it's so crucial for continuous delivery?
Well, it's all about keeping a close eye on how your applications and infrastructure are doing in production. It's like having a constant stream of data telling you how things are performing.
So like a fitness tracker for your applications.
Haha, yeah, that's a great way to put it.
It helps you spot potential problems before they become big headaches.
Exactly. You can identify issues early on, gather performance data, and ultimately make sure your users are having a smooth experience.
That makes a lot of sense.
hmm
But with all that data coming in, how do you make sense of it? How do you actually know what to do?
That's where tools and strategies for data visualization and alerting come in. You can set up dashboards to see key metrics in real time and configure alerts to notify you if something goes wrong.
So it's not just about collecting data, it's about understanding it and using it to make decisions. Precisely. Monitoring is only valuable if you can turn that data into actionable insights.
That's a great point. Now, before we wrap up this part of our deep dive, I want to touch on something the book really emphasizes: collaboration.
Collaboration, yes. That's at the heart of it all.
It is. Why is it so crucial for continuous delivery?
Well, continuous delivery isn't just about tools and technology. It's about people working together effectively.
That makes sense.
You need to break down those walls between developers, testers, operations folks, and even the business side.
So it's about creating a shared understanding of what you're trying to achieve.
Exactly. And building a culture where everyone is invested in delivering high-quality software. That's what makes continuous delivery truly successful.
That's a great point to end on for part one. We've covered a lot, from automating deployments to managing infrastructure like it's code.
It's been quite a journey so far.
It has. But we're just getting started. Stay tuned for part two, where we'll delve even deeper into the practical aspects of continuous delivery.
I can't wait. And, that collaborative spirit, it's really what the whole DevOps movement is all about.
DevOps, right? The book mentions that.
Yeah, it's about bridging the gap between development and operations.
Yeah.
So you can release software faster and more reliably.
Like a well-oiled machine where everyone's working together seamlessly.
Exactly. And a big part of that is this commitment to continuous improvement. The book really stresses that.
So continuous delivery is not a one-time thing. It's an ongoing process.
Oftenly. It's a journey, not a destination. It's all about constantly evaluating, refining your processes, automating what you can, and always learning.
Always striving to get better, basically.
Right, always improving. Now let's circle back to version control for a second.
Okay, back to version control.
The book lays out some really important principles for using it effectively.
All right, what are some of the key takeaways there?
Well, one of the most important things is committing changes frequently,
Frequently, how often are we talking?
like multiple times a day, at least a couple of times.
Wow, that's a lot.
It is, but it keeps those changes small, which makes them less likely to break things.
And it helps avoid those massive merge conflicts that can be such a pain.
Exactly. It's like instead of making one giant change, you're making a bunch of tiny ones.
Smaller steps are easier to manage.
Right. And speaking of small steps, the book talks about this concept called done means released.
Done means released. Okay, what does that mean?
It's about challenging the traditional idea of done in software development.
I'm intrigued.
Think about it. In a continuous delivery world, a feature isn't really done until it's actually providing value to users, right?
So it's not enough to just build it, you have to get it out there.
Right. Ideally, it's been released to production. That's what truly done means.
Makes sense. But I can see how that might not always be practical.
You're right, it's not always feasible, especially in the early stages of a project or if a feature needs a lot of testing.
So what's the alternative?
The book suggests showcasing the feature in a production-like environment to people who represent the users.
Ah, so like a sneak peek before the official launch.
Exactly. You get valuable feedback early on without the risk of a full production release.
That's a smart approach. Now, the book also talks about some common anti-patterns, things that can really trip you up on your continuous delivery journey.
Ah, yes. The pitfalls. We've all been there.
We have. So what are some of the things we should be watching out for?
Well, one common trap is manual configuration management.
Oh, I've seen that one before. It's like, it works on my machine, but nowhere else.
Exactly. It leads to inconsistencies between environments, making it hard to reproduce issues and fix them.
So how do you avoid that mess?
Automate. The book is big on automation. Use tools like Puppet or Chef to define your infrastructure configuration as code. That way, everything's consistent and reproducible.
So no more manual tweaking and hoping for the best?
Exactly. Another common anti-pattern is deploying differently to different environments.
Oh, yeah, I can see how that would be a problem.
It introduces those little variations that can cause unexpected issues in production.
If your testing environment isn't like production, you're in for a surprise.
Right. That's why the book stresses using the same deployment process for every single environment.
From the developer's laptop all the way to production.
All the way. Yep. Consistency is key.
Got it. Consistent and repeatable. Makes sense. Now let's talk about continuous integration.
Yes, CI, the bread and butter of continuous delivery.
The book calls it an essential practice, maybe even as important as version control.
Absolutely. It's all about integrating changes often, like multiple times a day, and running automated tests to make sure the code is always working.
So it's like having a safety net that catches errors early.
Exactly. It prevents those integration nightmares where you spend days, sometimes weeks, trying to merge code, only to find it's broken and full of conflict.
Been there, done that, not fun.
Not at all. But continuous integration helps avoid all that. Now, for it to work well, there are a few things you need.
Okay, like what?
First, developers need to commit their code regularly, at least a couple of times a day, ideally.
Right, those small incremental changes we talked about earlier.
Exactly. They're crucial for smooth sailing. Second, you need a good suite of automated tests. They're your safety net, catching errors quickly and providing feedback. And third, you need a culture that values fixing broken builds immediately.
Oh yeah, a broken build can really throw a wrench in the whole process.
It can. It's like hitting a roadblock on the highway. The book actually advocates for a never go home on a broken build policy.
Wow, that's serious.
It is. Fixing a broken build should be the top priority for everyone.
It makes sense though. If you let it linger, it can turn into a much bigger problem.
Exactly. Now, another practice that goes hand in hand with continuous delivery is test-driven development, or TDD.
Okay, TDD. I've heard of that, but I'm not sure I totally get it.
It's actually pretty simple. You write automated tests before you write the actual code.
Wait, so you write the test first and then the code to make the test pass.
Exactly. It seems a bit backwards at first, but it has some big advantages.
Like what?
It makes sure your code is testable from the get-go, and it gives you a solid set of tests to catch regressions, those bugs that creep in when you make changes.
I see. So you're basically building a safety net as you're building the software.
Precisely. And it forces you to think about how your code will be used, which leads to better design.
Makes sense. Okay, let's get into the nitty-gritty of the deployment pipeline. The book breaks it down into several stages, starting with the commit stage. Can you walk us through that first step?
Sure. The commit stage is where the continuous integration magic really kicks in.
The magic happens.
It does. This is where you compile the code, run unit tests, do some static analysis, make sure everything's in order.
So it's like a quality check to make sure the code meets the basic standards?
Exactly. If everything passes these initial checks, the code is packaged up and sent on to the next stage.
Makes sense. Any tips for making the stage run smoothly?
Treat it with the same care and attention as you treat any other part of your code.
Okay, so it's not an afterthought.
Not at all. Your build scripts, your test suites, they all need to be well-designed and efficient. And speed is crucial.
Why is speed so important here?
Because a fast commit stage gives developers quick feedback. If something breaks, they know it right away and can fix it.
So it keeps the development process flowing smoothly.
Exactly. No one likes to wait around for a slow build. The book even offers some tips for writing fast unit tests, which are essential for a speedy commit stage.
Oh, I'd love to hear those tips. How can we make sure our unit tests don't slow us down?
Well, keep them focused. Each test should focus on one specific thing, avoiding interactions with external systems like databases or networks.
Keep them isolated, in their own little world.
Exactly. And to do that, the book recommends using test doubles, things like mocks and stubs.
Ah, mocks and stubs. I always get those confused. Can you remind me what the difference is?
Sure, think of them as stun doubles in a movie.
Mm.
A stub is a simple stand-in. It just provides canned responses to method calls. A mock is more sophisticated. It has expectations about how it should be called and can verify those expectations.
So a mock is like a demanding director, making sure everything goes according to plan, while a stub is more laid back.
Exactly. Now, beyond test doubles, make sure your code is designed for testability from the beginning.
Okay, any tips for that?
Avoid hard coding any delays or waits in your code. If your tests need to wait for something, use techniques like polling or callbacks. It keeps things fast and efficient.
Got it. Fast tests, fast feedback. Okay, let's move on to the next stage. Automated acceptance testing.
Acceptance testing, that's where you really start testing the value of your software.
The book says it's crucial for going beyond basic continuous integration.
It is. With acceptance tests, you're not just checking if your code works technically. You're checking if it actually meets the needs of the users.
So it's not just about whether the software works, but whether it does what it's supposed to do.
Right. Acceptance tests focus on the what, not the how.
I like that. The what, not the how. But why are automated acceptance tests so important for continuous delivery specifically?
Well, think about it. If you're releasing software frequently, You can't rely on manual testing all the time.
It would take forever.
Exactly. Automated tests are faster, more consistent, and they can be run much more often. They're your safety net against releasing software that doesn't work as intended.
I can see that. Now, the book mentions this visual called the testing pyramid. Can you explain that?
The testing pyramid is a way to think about the different levels of testing and how much effort you should put into each one.
Okay.
At the bottom are your unit tests. They're the most numerous and the fastest to run. Then you have component tests, which test groups of components together. And at the top, the pointy part of the pyramid, you have your acceptance tests.
Got it. So it's like a hierarchy of tests.
Right. And it's about having a balanced testing strategy. You need a strong foundation of fast, focused unit tests, and then a smaller number of broader acceptance tests at the top.
It's like building a pyramid. You need a strong base.
Exactly. And the book offers some good advice for actually implementing those acceptance tests.
Okay. What are some of the key points?
Focus on the behavior of the application, not the technical details.
So what the software does, not how it does it.
Right. And use a layered approach.
Layered approach. Okay. How does that work?
First, you have your acceptance criteria. These are the high-level statements of what the system should do.
So that's the starting point.
Yes. Then you have the test implementation, where you translate those criteria into actual code.
So you're taking those high-level descriptions and turning them into concrete tests.
Exactly. And then you have the application driver layer.
The application driver layer, what's that?
It's an abstraction over the application's user interface or API. It makes the tests easier to write and maintain.
Ah, okay. It's like a bridge between your tests and the application itself.
Exactly. Now, the book also recommends using a domain-specific language, or DSL, for writing your acceptance tests.
DSLs, those are like creating your own custom language for testing, right?
Exactly. And a well-designed DSL can make your tests much easier to read and understand, even for people who aren't programmers.
It's like speaking the language of the business rather than the language of code.
Precisely. Now, one thing to avoid is writing acceptance tests that are too tightly coupled to the user interface.
Why is that bad? Wouldn't you want your tests to reflect how users actually interact with the system?
Yes and no. You want to test the UI, of course, but if your tests are too closely tied to the UI, they become very fragile.
Fragile, how so?
Even small changes to the UI can break a ton of tests, making them a nightmare to maintain.
So you need to find a balance. Test the UI, but keep your tests robust.
Exactly. And the application driver layer we talked about earlier can help with that. It acts as a buffer between your tests and the UI, making them less sensitive to changes.
Ah, that makes sense. And what about managing test data for these acceptance tests?
Good question. The book has some good advice for that, too.
Okay, let's hear it.
First, avoid using a copy of your production data for testing.
Why is that? Wouldn't it be the most realistic?
It would, but it's also risky. Production data can be huge, complex, and might contain sensitive information.
Oh, right, security concern.
Exactly. It's much better to create a smaller, controlled set of data specifically for testing.
So you're not putting your real data at risk.
Right. And another tip is to automate the process of setting up and tearing down that test data.
So no more manual setup and cleanup.
Exactly. It ensures consistency and eliminates surprises.
Makes sense. Automation, consistency, less risk. Okay, what about performance? How do you make sure those acceptance tests run quickly?
Well, just like with any code, look for ways to optimize.
Optimize, okay.
Find common patterns in your test setup and make them reusable. And if possible, run your tests in parallel.
Parallel, like running multiple tests at the same time.
Exactly. It can significantly reduce the overall time it takes to run your tests.
That's a great idea. It's like having a whole team of testers working at the same time.
Exactly. Now let's talk about something that often gets overlooked, but it's super important. Non-functional requirements.
Non-functional requirements.
Yeah, things like performance, security, usability. They're not features, but they're crucial for a good user experience.
Right, they're like the behind-the-scenes stuff that makes everything run smoothly.
Exactly. And the book emphasizes that these non-functional requirements need just as much attention as the functional ones, especially in a continuous delivery environment.
So you're not just releasing features quickly, you're releasing features quickly that perform well, are secure, and easy to use.
Exactly. And the book specifically talks about managing capacity.
Capacity, like making sure your application can handle a lot of users or traffic.
Exactly. It's like making sure your car has enough horsepower to go up a steep hill.
So how do you make sure your application can handle the load?
Well, the book cautions against premature optimization.
Premature optimization, what does that mean?
It means focusing too early on performance and capacity can lead to overly complex code.
Ah, I see. So you don't want to over-engineer things too early in the process.
Right. It's about finding the right balance. The book recommends a more balanced approach.
Okay, what does that look like?
First, you need to figure out what good enough means in terms of capacity for your application.
So what are your performance goals?
Exactly. Once you have those goals, you can design your application and infrastructure to meet them.
And then test, test, test.
Right. Regular capacity testing is crucial. Things like load testing and soak testing.
Load testing and soak testing. Can you remind me what those are?
Load testing is simulating a lot of users or traffic on your system to see how it performs under pressure. Soak testing is running the system under a sustained load for a long time, like hours or even days.
Ah, so it's like stress testing for your software.
Exactly. Now, the book also points out some common mistakes people make with capacity testing.
Okay, what are those?
One is using unrealistic workloads in your tests. If your tests don't reflect real-world usage patterns, the results won't be meaningful.
Right, so make sure your tests are realistic.
Exactly. And another mistake is testing in an environment that's very different from your production environment.
Why does that matter?
Because the performance of a system can be affected by all sorts of things. Hardware, network configuration, operating system. If your testing environment isn't like production, your results might not be accurate.
So keep it real.
Exactly. The more realistic your testing environment, the better.
Got it. Okay, what about instrumenting your application for capacity testing? What does that even mean?
It means adding code to your application that collects data about its performance.
So you're basically adding sensors to your code to see how it's doing.
Exactly. It helps you identify bottlenecks and optimize for performance.
Makes sense. Any tips for choosing the right tools for capacity testing?
Think about your application, the expected workload, your budget, and the skills of your team.
So it depends on your specific situation.
Right. No one-size-fits-all solution.
Okay, now let's talk about the exciting part. Deploying and releasing applications. The book offers a great guide for creating a release strategy.
Ah, release strategies. That's where it all comes together.
So a release strategy is basically the plan for how you get your software into the hands of users.
Exactly. And the book really emphasizes planning carefully. You need to think about your application, your users, the environment, your risk tolerance, all sorts of factors.
So it's not as simple as just pushing a button.
It can be, but you need a good plan in place first.
Makes sense. What about deploying and promoting your application through different environments?
The book recommends a staged approach.
Staged approach. What's that?
You start with a development environment, then move to testing, then staging, and finally production.
So it's like a series of checkpoints along the way.
Exactly. And each environment should be as close to the production environment as possible. That way you catch issues early. And of course, automate everything you can.
Automation. We meet again.
It's everywhere in continuous delivery. It reduces errors, makes things repeatable, and speeds everything up.
Love it. Now, the book mentions a few different deployment strategies, like blue-green deployment.
Ah, blue-green deployment. Remember we talked about that for databases?
Yes, it's where you have two identical production environments and switch traffic between them.
Exactly. It minimizes downtime and makes it easy to roll back if you need to.
So it's like a safety net for your deployments.
Precisely. Another strategy is canary releasing.
Canary releasing. I haven't heard of that one.
It's where you release a new version to just a small group of users first.
Oh, so you're testing the waters before rolling it out to everyone.
Exactly. It lets you gather feedback and catch any problems before they impact a wider audience.
That's smart. What about database deployments?
Databases are often the trickiest part. The book recommends taking an incremental approach. Break down large changes into smaller steps.
So baby steps.
Exactly. And automate as much as you can.
Automation. Always. Okay, what are some common deployment mistakes to avoid?
One big one is deploying straight to production without testing in other environments first.
That sounds risky.
It is. It's like performing surgery without practicing first. And another mistake is making manual changes to the production environment.
But sometimes you need to make quick fixes, right?
I know it's tempting, but those manual changes are hard to track and can cause inconsistencies. It's much better to use tools like Puppet or Chef to manage your configuration.
So everything is documented, tracked, and automated. No more surprises.
Exactly.
This has been such a great discussion about deployment and release strategies. Now let's touch on managing infrastructure and environments for continuous delivery.
Ah, yes. Setting the stage for success.
Exactly. A book highlights the importance of treating infrastructure as code.
Right, which we talked about earlier. It's all about applying those same principles of version control, automation, and testing to your infrastructure.
So you're basically creating a blueprint for your entire IT environment that you can manage just like code.
Precisely. And it has so many benefits. Reproducibility, testability, fewer errors, faster setup times.
It's a win-win. And tools like Puppet, Chef, and Ansible make it all possible.
Absolutely. They automate the process of setting up and configuring your servers.
Like having an army of robot sysadmins? What about the cloud? It seems like everyone's moving to the cloud these days.
They are. And the book has some good advice for managing cloud infrastructure.
Okay, what are some key considerations for continuous delivery in the cloud?
Well, security is always top of mind. You need to make sure your cloud environments are secure and your data is protected.
Especially with all the data breaches we hear about these days.
Exactly. And cost management is important too. Cloud computing can be very cost effective, but it's also easy to overspend if you're not careful.
So keep an eye on those cloud bills.
Definitely. And another key point is monitoring.
Monitoring, always monitoring.
It's crucial. You need to keep an eye on your infrastructure and applications in the cloud, just like you would anywhere else.
Makes sense. What are some good practices for monitoring in the cloud?
First, figure out what you need to monitor. What are the key metrics that will tell you how things are doing?
So choose the right indicators.
Exactly. Then figure out how to collect that data. There are lots of tools and techniques available.
Right, find the right tools for the job.
And once you have the data, you need to make sense of it. Create dashboards and alerts to help you spot problems quickly.
So it's not just about collecting data, it's about understanding it and taking action.
Precisely. Okay, now let's switch gears again and talk about data management.
Data, the fuel that powers so many applications.
It is. And the book has some good advice on managing database changes and migrations in a continuous delivery environment.
Okay, let's hear it. What are some effective database strategies?
Automate, automate, automate. Just like with everything else, automate the process of applying database changes.
Automation, the continuous delivery superhero.
It is. And break down big changes into smaller incremental steps.
Baby steps.
Exactly. And of course, test everything thoroughly before you deploy to production.
You don't want to mess with your data.
Definitely not.
Ugh.
Now, what about managing test data for your databases?
Oh, good point. That can be tricky.
It can be. The book recommends using synthetic data whenever possible.
Synthetic data.
It's like fake data, but it mimics the characteristics of real data without containing any sensitive information.
So like test dummies for your data.
Exactly. It's safer and easier to manage.
Makes sense. What about specific techniques for deploying database changes?
Well, blue-green deployments can work really well for databases. You can test your new database schema and data migration in a safe environment before going live.
So you're basically doing a dress rehearsal for your database.
Exactly. And feature toggles can also be useful. You can deploy new database changes, but keep them hidden from users until you're ready to flip the switch.
That's a great way to control the rollout and minimize risk. Now let's talk about managing components and dependencies, which are the building blocks of modern software.
Components are great, but those dependencies between them can be tricky to manage.
Especially in a continuous delivery world where things are constantly changing.
You're telling me.
Yeah.
But the book has some good tips.
Okay, lay them on me.
First, version your dependencies carefully. Be very specific about which versions of each component you need.
So keep track of those version numbers.
Exactly. And use a dependency management tool like Maven or Ivy.
Ah, yes, the librarians for your software components.
Exactly. They make sure you always have the right versions of everything.
I love that analogy. Now, beyond managing existing dependencies, the book talks about designing your application for componentization from the start.
Right. It's about breaking down your application into smaller, more manageable pieces that can be developed and released independently.
So it's back to those Lego blocks. Each brick is a component.
Exactly. And it has so many benefits. Your code becomes more modular, easier to understand, easier to maintain, and different teams can work on different parts without stepping on each other's toes.
That sounds incredibly efficient. What are some things to keep in mind when designing components?
Well, define clear boundaries between them. Each component should have a specific job and should talk to other components through well-defined interfaces.
So it's about good organization and clear communication between the components.
Exactly. And try to keep your components as independent as possible. Minimize dependencies and make sure each component can be developed and tested on its own.
So back to that idea of loose coupling.
Precisely. Now let's get into some advanced version control techniques.
Oh, I'm ready to level up. What are some of the more advanced strategies?
The book talks about branching strategies, merging techniques, and distributed version control systems.
Okay, let's start with branching strategies. What are the options and how do you choose the right one?
One common approach is to create a branch for each new feature or bug fix.
So developers can work on their own little corner of the code base without affecting anyone else.
Exactly. And once the work is done and tested, they merge it back into the main code base.
Okay, that makes sense. Are there other branching strategies?
Another option is to use feature toggles, which we talked about earlier.
Right, the secret switches for your features.
Exactly. They give you a lot of control over when and how you release new features. Yeah, you can turn them on or off without redeploying anything. It's pretty cool.
I bet that simplifies things a lot. Now, the book also talks about merging branches effectively. It sounds like merging can get tricky if there are conflicts.
It definitely can. But don't worry, the book has some good advice for that too.
Okay, let's hear it. What are some best practices for merging?
Well, one tip is to merge frequently.
Merge frequently.
Yeah.
Yeah.
Yeah, it's like the more often you merge, the less likely you are to run into big, nasty conflicts.
It's like cleaning your house, right?
Exactly. If you do it a little bit every day, it's much easier than waiting until everything's a complete disaster.
I can definitely relate to that. So, frequent merging is like those small incremental changes we talked about earlier.
All right. It's a good habit to get into. And another tip is to, just talk to each other.
Talk to each other, as in,
Yeah, communicate. If you're working on something that might overlap with someone else's work, just chat with them about it.
coordinate your changes and avoid those conflicts in the first place.
Exactly. A little bit of communication can go a long way.
Makes sense. Now, the book also talks about distributed version control systems, or DVCSs.
DVCSs, like Git.
Yeah, Git. What are and why are they so good for continuous delivery?
Well, with a DVCS, every developer has a complete copy of the codebase on their own machine.
Okay.
So they can work offline, commit changes locally, and experiment without messing anything up for everyone else.
So it's like having your own private playground for code.
Exactly. And when they're ready, they can share their changes with the rest of the team.
Sounds pretty efficient. What are some of the advantages of using a DVCS compared to like a traditional centralized system?
Well, for one, they're super fast. Because most operations happen locally, developers don't have to wait for a network connection.
So it speeds up the whole development process.
It does. And they're more resilient, too.
Resilient? How so?
Well, if the central server goes down, everyone still has a copy of the entire code base on their machine.
Ah, so it's like having a backup.
Exactly. And they're more flexible, too. You can easily experiment with different branching strategies and workflows.
Okay, so DVCSs sound pretty awesome. Now let's zoom out a bit and talk about managing the continuous delivery process as a whole.
All right, the big picture.
The book offers some good advice on making sure everything runs smoothly and efficiently. What are some of the key takeaways there?
Well, one recommendation is to establish a maturity model for your continuous delivery process.
A maturity model, what's that?
It's basically a framework for assessing how well you're doing with continuous delivery.
Okay,
It outlines different levels of maturity, from basic to advanced.
I see. So it helps you figure out where you stand and where you need to improve.
Exactly. It's like a roadmap for continuous delivery.
Makes sense. What about risk management? The book talks about that too.
Risk management is crucial. Continuous delivery involves releasing software frequently, which means you're constantly making changes. And change always comes with some risk.
So you need a plan for dealing with those risks.
Exactly. The book outlines a process for identifying, assessing, and mitigating risks.
Okay, how does that work?
First, you brainstorm potential risks. Then you assess how likely they are to happen and how bad the impact would be if they did.
So prioritize the risks based on their potential severity.
Right. And for the high priority risks, you come up with mitigation plans. Those are basically your backup plans, just in case something goes wrong.
I like that. Always have a backup plan. And I'm guessing risk management is not a one-time thing.
Definitely not. You need to monitor those risks throughout the project and update your plans as needed.
It's an ongoing process. Makes sense. Now, the book also provides a list of common delivery problems and their potential causes. I bet that's super helpful for teams trying to figure out what's going wrong.
It is. It covers everything from infrequent deployments to poor application quality,
Mm-hmm.
and it gives you some ideas on how to fix those problems.
Okay, what are some warning signs that a team's delivery process might be in trouble?
Well, if you're only deploying once a month or less, that's a red flag. It probably means your process is too slow and manual.
Gotcha.
Another red flag is finding a lot of bugs in production.
Yeah, that's never a good sign.
It could mean your testing process needs work, or maybe your development practices aren't so great. And if your team is constantly stressed and working overtime just to get releases out the door, that's a sign that something needs to change.
So it's important to pay attention to those warning signs.
Absolutely. Don't ignore them. The book offers some general advice for addressing these common problems.
Okay, what are some of the solutions?
Automate as much as you can. We've talked about this a lot, but it really is the key.
Automation, the continuous delivery champion.
It is. And improve communication and collaboration. Break down those walls between teams and work together towards a common will.
Teamwork makes the dream work.
Exactly. And finally, create a culture of continuous improvement. Always be evaluating. Always be looking for ways to do things better.
Always be learning.
Yes. Continuous delivery is all about constant learning and improvement.
Well, this has been an amazing deep dive. We've covered so much about continuous delivery, from the basic principles to the practical details. Any final thoughts you'd like to share?
Just remember, continuous delivery is not a magic bullet. It's a journey, and it takes time and effort to get it right. But the rewards are well worth it. If you can embrace the principles we've talked about, you can transform the way you build and deliver software.
And ultimately deliver more value to your users.
Exactly.
Well, I think that's a wrap on our continuous delivery deep dive. It's been a pleasure exploring this topic with you.
The pleasure was all mine.
To all our listeners, thanks for joining us on this journey. We hope you found it valuable and insightful. Until next time, happy coding.